So for those of you that were here yesterday, we had our high school business contest, and that was actually the biggest group of high schools we've ever had. And I did a couple of contests in here, and I actually had a lot of students asking about programming and some other things. So it was interesting to see some of them. In fact, apparently I was a slacker in high school. We had one student on campus who has managed to get a $600,000 grant as a high school student to start some programs. So, yow. So it was pretty exciting. I know you guys were overwhelmed. If you went to the cafeteria, I apologize for the karaoke. If you managed to miss that, that was probably good. Nothing like 400 high school students singing karaoke. It was exciting. So we want to start out with this idea. We left off with the idea of arrays, and really arrays are just a set of buckets, and we call that bucket, so we can call it just like we would a variable name, but now we call a subscript for each one of those buckets, and we start at 0 to the limit of our buckets. So if I said I will have an array of 20 buckets, I want to store items, that's that variable name, subscript 0 through 19. And what's really nice is I can run a second variable, a counter, through there, and that lets me scroll through that array of items. And I can do our matching and some other things to look and see if that's something we want to do. Well, we can expand this a little bit, and we get to the idea of something called a parallel array. And this is where we put two arrays, so there's different names. So one is my variable, and the other one's my variable 2, or whatever we want to think about it. But we put them parallel to each other. So a subscript, then, is how we relate those. So the picture might make a little more sense. A picture, if I get to the right spot, might make a little more sense. So something like this. I have two arrays. So here we have, in this case, so at array 0 for valid item and for valid price, I can link those together. So think of this as you go to the grocery store and you pick up a gallon of milk. How does that gallon of milk, how does the checkout counter know what that price is? There's a barcode. So think of this item code up front as that barcode. The bottom one is the price. That's really internally what we have here. And so we can use those parallel arrays to form a structure that's very powerful. So now we have a way that we could link, maybe that's student ID and your grade in this class. So we have a linkage between the two of those. And we could make those 3 or 4 or 10 levels deep if we really wanted to. But these parallel arrays are very, very powerful. So if we design a program, so this one is checking for an item's price. So if I look at the program here, first thing it's going to do is we have all these declarations up there. And in fact, in the top of that, we actually declare all the item numbers and all of the prices. And notice we declare an array and we say it's 6 units. But we don't use a mystery number. We actually use a constant up there. So size equals 6. So our little grocery store is kind of whack. It only has 6 items. But it demonstrates this concept. We use this idea of a subscript, and we set that subscript equal to 0 at the beginning of our loop here. If subscript is less than size, so is 0 less than 6? Yep. And here we come down and we check, is that item found? And if so, we know that we can set a price for that item. So we check for it, and we found it, and then we escape over here, and now we actually output the price and the quantity. So this is nothing more than our grocery store program. This is the same idea, but this is the pseudocode for it, which depending on whether you're visual or if the coding makes more sense. So again, all of our declarations up front, we have our item, quantity, price, size, valid items, valid price. Here's our first loop to say, here we have an item, we found it, it outputs a price, so it says price equal to, and you output quantity at price equals total. So total we haven't defined yet. So total would be how many of those items times its price. So quantity and price. So otherwise, our other one, if found it doesn't equal yes, in other words, our sentinel value, then we just output whatever our message for no is that says item is not available or item not found. So we're starting to get a rudimentary way that we can use those parallel arrays. Could we have a third array that's also parallel in there? So the third item might be item size or item number, our price, and a description. That description could be in there, and that could be a third item. Once we find the item number and we know that subscript, so if it's at subscript 3, which would be item number 405, we know its price is 1, 2, 3, 4, so $15.99. And if we had a description, we could also output that description based on that subscript. So this is, once you use these and they make sense to you, you'll want to do arrays for all kinds of things. But using it the first time is a little tough, getting your eyes wrapped around it. So the other thing we can do is that search had a little problem. So when I created our search, one of the problems with that search is it checked every item in that array, but it didn't stop when it found the item. It continued to search through there. So notice, maybe it's easier to see here, that array is based on that subscript and that SUB variable, and it's going to go 0 through 5. And if we find the item on the first pass, it's still going to do that another 5 times. Does that seem like a waste, an inefficiency? Yeah, we want to make our life a little easier. So what we want to do is have a way that we can get out of that loop as quickly as possible. And I used our buddy, or the book they used this thing, the AND feature. So we know we can combine things. We can use AND. So now we're saying subsize less than size. So in other words, it's less than 6. And that variable we flipped called foundIt, and foundIt equals no. So this one, as soon as we catch the right item, it's going to flip foundIt to now is equal yes. That entire thing's going to invalidate, and it's going to dump right out of that loop. So it's pretty clever. We just added a little bit of extra coding to flip that out as quick as possible. So think about that when we start designing this. How do I make things efficient? Yes, our computers are powerful. Does that make any sense, though, to loop 5 or 10 or 1,000 times when we don't need to? And we know from statistics that on average, we're going to have to go through half of that list to find the item we want, if they're randomly distributed. So we're going to have to, on average, go through half of that list. Well, that means we tend to be doing twice as many searches or loops through that search as what we really need. So we'll sit down and we'll look at one of these here in just a second, and it'll make more sense, hopefully, when you do one. A couple of things we need to worry about here. Arrays can be great. Arrays can also be a little dangerous. So you declare an array, and it's given a size. So you have those buckets. You have to be careful of the way that you address those buckets. So internally, the computer does do them in bytes. So I'm not going to overwhelm you with thinking about that right now. But what I want you to think about is, you have 6 buckets. What if I try to address the 7th bucket? Nothing explicitly says I can't look at valid underscore item bucket 7 But if I declared it as 6, do we know what's hiding in that space on our computer? And actually, this is a way we actually can break things. So we're looking at data, we don't know what's in there. So we also need to make sure that our arrays are always the same data type. So if they're all strings, our programming language allocates the same space for each group. So if it's a character string, it may be 255 characters for each string. If it's a number, it's got a finite space. So we tend to not be able to, although some languages can, it's not really good practice, to have different types of data in those buckets. You either are wasting a lot of data or you're going to cause another issue. So if I set them all up as text strings, they're 255 characters long, and I store a 4-digit number in there, I've wasted a lot of character space. Because those buckets we define ahead of time, and they're not very mobile, so we've wasted a lot of storage space. In addition, we'd get that number back, and while we think it's a number, it looks like a number, it's 4,122 or something, but the reality is it's a string, and we're going to have to treat it a little differently to work with it. So the biggest thing is we need to make sure that we're inside those buckets. And when we do a search or a loop, if I would do an equals instead of a less than for that size, we could get out of our array or out of bounds in our array. So, example of that. So here we have our string. So we created every month of the year. So we said here we have an array. And it's got January through December, so it's got 12 buckets. And so we input month. So we're going to put mon equals mon minus 1. So it changes it from the way we think to the way the computer thinks. So if you want to output a month, you put in month 12, it's really stored in bucket 11 because it's 0 through 11. So that's all this program does. Here we don't have any error checking. We're just going to output whatever month and that subscript that you typed in. Well, people are notoriously idiots. If you say, hey, only put in numbers 1 through 12, what do you usually type to try it? You put in a 15 just to be kind of obstinate? A lot of people do. And in this case, if I type in the month 15 because I just want to see what's going to happen, it's going to say, okay, so 15 minus 1, so it's going to try to output whatever's in this array at subscript 14. Does that exist? It's out of bounds. It's out of an array. So we need to come up with some kind of an error checking procedure to make sure that that array, we stay within that. So really quickly, what I would do for something like this is I would actually build that input where you're getting it from a user in a loop. And that loop is contingent on them putting in the right value. If it's outside of the value, so if it's less than 1 or greater than 12, what they put in, it asks them that question again. And so it would loop until they put in a value between 1 and 12. It's kind of an error checking. So we need to make sure that logically we do those kinds of things. People are idiots. Always remember that when we start looking at that. I guess that's valid for about any of our classes, quite frankly, that people will be idiots. So if I get a number, so I tried to do that 14, bucket 14. Depends on the language what's going to happen. Some languages handle it really gracefully, and they go, oh, this seems to be out of bounds. You might, and it'll send some kind of an error condition. The higher level languages tend to do that, or they'll come back and say, hey, that bucket's not defined. Some kind of handy-dandy error message. If I'm using a lower level language, so if I'm using something like C++ or below, or I'm using an assembler language, it's not smart enough, it doesn't have enough processing capability to look at that, and it's just going to give you whatever would be in that bucket. So if it would extend that array out, so it might give you data about another program. Oh, wait a minute, this might be a security flaw. it might give you something else. We don't know what it is. It's going to be garbage to you. So, they have this term out of bounds. When you try to get an array and it's not within the range of the created array, you're considered going out of bounds. We try not to do it on purpose unless we're writing a script to try to break for example, an HP server switch. Oops. So, we always want to test to make sure that array. We want to make sure that when we create those arrays, we kind of sketch out what we're trying to do. Have some way to check those arrays. Just a really handy way. They're a great tool. So the other thing that's kind of handy that we haven't talked about but makes sense is we're going to tell you about another kind of loop. You never have to use this if you don't want to. They are handy. It's a shortcut. Everything can be done with the while loop, but this is very handy if I know that I need to do something a finite number of times. And we can create what's called a for loop. So for loop. So here we have a loop, and instead of having to go through a while and say less than, similar style of loop, but instead we say for. So our DEP are variable dependent, whatever we're looking at. 0 to size, and size we set at 5, minus 1. So in other words, it's going to go to 4, step 1. So the key to that is you're saying for a variable where you're going from 0 to 37 or whatever, step 1 or step minus 1. See, if you wanted to go backwards, you can do that. And so the for loop, here we actually explicitly again say end for loop. But in most programming languages, you don't do that. And we already saw in Python, we don't even do the end while loop. So we would really just have a for loop. It goes from one number to another in an increment that we define. And it's very handy for a loop. So it's in that, no, it's underneath the declarations where we have this for loop here. So we'll look at those. The for loops are really handy when I want to look at an array because I know what size an array is. And if I want to loop my way through that array, I have that ability to do it. So this case, all it's doing is saying, here we have an array called departments, and we made it 5 units, and it's going to output all 5 of those really, really quickly. So it's just a handy way. So for loops are just a really quick little shortcut that we've developed. Internally, the computer's still doing it like a loop, a while loop, but it's easier for us to just write this one line that says, for x equals 1 to 5, step plus 1. And then we have a really quick way to do that. So when we do things like counters and very quick, we're going to search through an array, this is a really quick way to set that up. Now, there's a problem with this. It's going to go all the way through whatever. So if we had size was equal to 5,000, it's going to go through all of them. Which in this case, that's what we wanted it to do, was output the results of that. If I'm searching through a loop, we have to probably come up with a little better plan, and the while loop makes more sense because I can break out of it a little easier. There's ways to break out of for loops, but it kind of goes unstructured. It's not pretty to do it that way, but we're going to see a lot of that. So, your assignment this week, let me go back and open it really quickly. If I go back in our book, which hides in week 1, I'm sure I have it downloaded 37 times on this computer, but I'll do it anyway again. Again, probably a quicker way to scroll through it. 3 basic structures. So at the end of chapter 3. So we talk a lot about arrays, but sometimes it makes more sense to think about one. exercises sometimes are kind of an easy way to look at it. So we can create an array. See if I can find one that does a nested array. Our assignment's 5B, right? Got it. And I think I have something I will show you for 5A. So let's look at 6 here. Yep. So I'm going to look at 6, and we're going to see if we can design some logic for this. So this particular restaurant, the Billy Goat fast food restaurant, sells products shown in the table. So we want a read that reads in the name of an item ordered by a customer and outputs either the correct price or the message, sorry, we don't carry that product. So let's think about the logic of how we might do this. So the customer's going to put in an order. We're going to search for that product, and we're going to see if we can output the correct price for it. All right. So do we want to do this pseudocode, or are we going to draw a flowchart? Flowchart? I'm okay doing either. It's hard to draw on the screen the flowchart, but we can look at it. But let's think about the logic behind this thing. So we're going to have two parallel arrays. So if you notice, we're going to have product as an array and price as an array. And so when somebody has an item that matches cheeseburger, we're going to look at that same subscript and then translate that to that price. So let's do first, just because I have it handy here. Let's do it first and see if we can do kind of the pseudocode. So we know a couple of things about this right away. See if I can scroll over in this page. There we go. So we know in our declarations, we're going to have a couple of items in there. So we know we're going to have a product array. And that product array is going to have a set of items inside of it. I don't know what that size is yet, so I'm going to use size. So that's going to declare our array for product. And I'm going to go in and assign the values that we know that are in there. So I'm going to put in cheeseburger. And I separate them with a comma. Pepsi. And notice I'm putting them in quotes, just kind of as a practice so we get used to that idea. So I'm going to put in a whole set of values, and I'm going to say, all right, I want these things all shoved into this array. Well, before I can declare an array, I need to figure out what my size is. So I'm going to use size, and I'm going to set that equal to a value. So right now we're going to set it as 3. So just as a note to myself, that means we're going to use 0 through 2 as subscripts. So if I reference something, so if I came down here, and I'm down in my main program, and I typed out print, and I'm going to show you just like what it would look like in Python. So we're going to print product. I could use any one of these values, 0 to 2. So if I did product 2, so that's what it's going to look like in Python if we use an array. It's going to print out product at the position 2, which is 0, 1, 2. So it's going to print out, the output's going to be chips. All right, so I kind of did this just as a test, to say, hey, that does make sense in my brain of what we're going to do. So size is equal to 3. We have 3 buckets for cheeseburger, Pepsi, and chips. And down here, this is just my test. So I'm going to just do this. I'm going to put a set of slashes in front of it. Just say that it doesn't have any content we're going to use, but maybe we might pick it back up again and use it again. So here we've defined product, and notice just because I made this a little small, there we go. All right, so if I define the word for product, and now that I know that my size, so I could do price. In the same way, I'm going to do size. And these are going to be prices, so I'm going to put 249, 1, comma, 0.59. So now I've created an array for both size and for, or the price and the product. So I've got my array. We're going to use some other variables. We'll look at those. So we know the first thing, and we're going to shortcut this a little bit, is we're going to say that the customer is going to input. So we're going to input, and let's call it selection. And I'm just going to explicitly say from customer, just so we see where it's coming from. So input our variable selection. So I'm going to come over here and I'm going to say, I'm going to declare this as a string selection. And I'm just going to set it equal to blank, just so we know that implicitly at the beginning it doesn't have anything. So these I really also need to declare that as a string. And I need to declare this as a numeric. And this clearly is a numeric. Just to clarify and make sure we're all on the same page. I don't know if I can get over wide enough and not lose the entire, there we go. So we know we're going to have string selection. So that's what the customer is going to put in. And so we're going to input selection. So we probably would have had a print statement that said, hey, please input the favorite food. And now we need to look through this loop and see if we have a product that matches that particular item. So I'm going to declare one more variable up here, and I'm going to call it sub. So I'm going to declare generic sub, and I'm going to set it equal to 0. And I'm going to use our friend the for loop. Because I know we've got to loop through at least 3 things, but I'm going to say for sub equals 0 to size step plus 1. So in other words, I'm going to do this. This variable is going to increase from 0 all the way up to the value in size, and it's going to do it in increments of 1. So inside of here in this nested piece is everything that's going to run inside of my loop. And so the first thing I'm going to ask, the first time through, I'm going to say sub. So we want to find out if they're equal. So I'm going to have this comparison. So I'm going to have the comparison of if selection is equal to product. Yep. Then we'll end in and we'll do an output. So if that's true, you're going to output, and we could do price, and it's going to be that same sub. Yeah. So because they're parallel, if one is if they put in cheeseburger, and cheeseburger is equal to cheeseburger, it's going to output the price. So this is 0, this is 0, so it's going to be price 0. So our else then, do we really need an else at this point? So only if we make it all the way through here. So right now we don't have a variable that's going to flip if it's yes or no. Right now, this is going to work if it's in that list. What happens if this doesn't work in there? So we could do it with an else statement. So right now, if it ever gets to be a value, the other one we could do is we could add another value out here. And so we could say, we could use our found it equals yes. So if selection equals sub, so only if this is true do we get a found it equals yes, right? So it works its way through, found it equals yes, and else we could explicitly say found it equals no, but there's a logic problem with that. So let's just leave this as is for now, just to see what happens. So let's think our way through there. We said found it equals yes. So we don't need to put the sub equals sub plus 1 because here in this loop, it's doing that for us. So all of this will loop and try every value from 0 to, in this case, 3. And it'll do it for us. So now, you've outputted that price. So if that's all you're going to do with that, you're fine. The problem's going to be if I want to pass this into something else. Because right now, it's going to go through 0. And if 0 is true, it's going to say, yep, the product equals the product. I'm going to output this product. And I'm going to flip my found it equals to yes. But I don't do anything else with it. And so I go to 1. Well, that's not true, so nothing happens. 2, nothing happens. But I haven't passed out that value anywhere else. So we might want to think about how we could pass that value out. So one of them might be, so instead of found it being a variable, is only if it's true do we pass this value for sub into a value called found it. And so I'm going to declare found it as a numeric. I'm going to set it equal to 0 here. We could then use that down here later, and you could say, well, let's print it as a print here. Print, thank you for ordering product, found it, at a price of So notice what we did was, even though, no matter what the product was selected, if it was 1 or 0, 1 or 2, this loop has to complete its loop. This would pass that value down, or that subscript value, into found it, whether it's 0, 1, 2, 3, 1,000, whatever it happens to be. And then we could reuse it again to then say, hey, thank you for buying a cheeseburger. So that gives us a tool that we could use to pass that out. Does that make some sense? So this loop has to run however many times that value of size. So if we set size to 30, well, we only have 3 items to start with, but we could fill up that array to 30, and we'd still be able to function. Because we're going to pass out a little bit of that subscript that we can reutilize. We're not changing our variable, which our variable here of product, that array has all these items. Now we'd probably want to add more items in, and it would certainly allow us to do that. But there's some problems with this. So this gets one product. Are you going to order just a cheeseburger? No, you're probably going to order So we have to come up with a little more content. So that would be product 1. So we'd probably need to build onto this a little bit. But this is how we'd manipulate those arrays to start looking at that. How do we start and peel this apart? So, small pieces, and we start building them. Remember, we only have 3 building blocks. The entire class, 3 different things. We have the selection, we have a sequence, or we have a selection, which is a question, a sequence, and we have a loop. And here we've used a couple of them. We have a sequence, we have a loop, and inside of that loop, we ask a question. And there are 100 different ways to do the same thing here. So we could rewrite that instead of using that for loop, which was a new technology. We could say this is a while loop. So while sub is less than size, then we're going to do this, and then do an end while. It does exactly the same thing. So we a lot of times will have multiple ways to do things. It just depends on which makes the most sense. I like for loops for this counting purpose. It lets us count through there pretty quickly. And here we could say, we could put in that explicit and found it. Here, if we flipped it to a different variable, so maybe we say, well, subsize, I guess that should be less than size, and found it does not equal 999, and only when we find the price, now we've reset it to 999, so only for that item, then it kicks it out that way. If we had to search through a big array, this makes more sense because as soon as it finds the item, it's going to kick it out. And if we do it that method, then we could use that sub out here because it stopped at wherever that selection was found. So there's always multiple ways we can do some of these problems. So this one's for the Billy Goat Restaurant. Here we have one that would be very similar. So here we have an application for payroll, and we have department number, department name. Well, that's going to work just like these here. Our problem is it's 5B I make you do. Well, to get to 5B, you have to do 5A. And so we can do a little thinking about this. What I have, and I have not turned it on yet, but I will really quickly, is I have a video for that one. If I can get back into the right class. Here we go. No, get back into the class. So this is me being the programmer. This is a video I created earlier. No, it's there is a video here, homework how-to video. So this is one I created going through step by step on that. It's about 30 minutes long. And I go through how to create part of the homework. So I would encourage you to use that when you start looking also. There is a quick way we can do it. I've also got, and it won't make sense until you watch through the video, I posted up here, and I will make that available at some point, one interpretation of how to do this. There are literally hundreds and thousands of different ways we could do that. That's one of the ways I will quite frankly say that we have found students who are cheating, which hopefully we don't ever have an issue in the future. But in this class, if you turn in something identical to somebody else's, then that's probably a really quick indication. So I also have a sample for number 6 that should be available. And so let me Pop that open. So this one I actually even have the flow chart for. So, or a flow chart. Is this the only way to do this? No. And so this is one solution. This one is a little different than the one we just went through. But it's another solution to this very same problem. And in fact, here we created an error message. So, same problem, different take on it. So here we have our declarations. Here we have item ordered. So instead of selection, here they just used an X because they're going to count through the loop. Found, size, price, and product are the same. And an error message saying, hey, we don't have that particular item. We use our shortcut for end of file. Here we say input item ordered. We go through and we search for it. If we find it, so here's our X values instead of sub values. We come out of this loop quickly. So it may make more sense looking at the code here. So again, we declared X, found, size, price, product, and error message. And instead of using a for loop, I did that all in this case in a big while loop. Now, there's a problem with this one I don't like, or something I don't like. As I have grown and looked at things, I no longer like using X's and J's and I's unless I have to. I like some documentation on what it is. Just so when I go back and I look at it, I understand exactly what I'm trying to do. In this case, I've just used X as a counter. And so X gets this loop here, and X is used as a counter in there, so X less than size. And I've used this to say if item ordered equals product of X, then output price. I assign size to the value of X. And I flip the value for found. I create 1, so I flip it to 1 so it'll exit out of here. Otherwise, I do X equals X plus 1, and I loop again. So, if found, by the time we get through that, so if we've looped all the way through our loop, if found is still equal to 0, so in other words, we flip it to 1 here if it is found, then it's going to output the error message. Otherwise, we input again and we loop back through until they get done. Again, it's the same problem. It's just another take on it, on how we could do that. So, what I would encourage you before you start the homework for this week, because this homework, it doesn't sound. Where do I have it here? Page. Nope. One of these I have it open. So this one says we have a school has 30 classrooms numbered 1 through 30. Each classroom can contain any number of students up to 35 students. Each student takes an achievement test at the end of the school year and receives a score from 0 to 100. Write a program that accepts data for each student in the school. That data would be things like student ID, classroom number, and the score. And it inputs it into some kind of an array. So that's a lot of students, but once we create that mechanism, so what is 30 times 35? What is that, 1,050 or something? So if this program worked, and it stored data for the maximum number of students, you're going to have a pretty good size array. So the homework, we'll go through that on that video, and I show you exactly how to set up parts of that. I don't give you everything because I want you to have to think a little bit. There are always ways that we can change and manipulate. So the first part of that, so 5A really says, design a program that lists the total points scored for each of the 30 classrooms. That lists the total points scored. So part B then says, modify 5A so that each classroom's average of the test scores is displayed rather than the classroom's total. So adding a total, each time we input one, we could add that value up pretty easily. So if I'm going to do that, I might have a smaller array. Do I need to store each student's grade individually? Accepts data for each student in the school, student ID, classroom number, and score on the achievement test. Am I taking data for every student? Yeah. So I'm creating a data structure to store that data. Well, that makes sense to use parallel arrays. So I could have an array for student ID, for classroom number, and score. So it's 3 items that are all going to be in parallel. And then I could list the points scored for each of the classrooms out of that data. I could run it so that I could do that. So this one's going to take some brain power and some thinking on it. It sounds simple, but then when we start trying to sketch it out or think about it, it takes a little brain power to think about that. Because you have a lot of different buckets in there. So pretty easily we could store the data. It's the getting the data back out to add it that's going to be the challenge. So the way I would probably do it is to get the data back out is with a set of nested loops. So those nested loops, I would look at each classroom, add up the totals for each classroom, and store that in an array. But this can get overwhelming if you start thinking about the entire problem all at once. Start thinking about smaller bits and pieces of it. So how could I do this in small increments? Well, first I want to think about how I'm going to structure that classroom and those students. So 30 classrooms, 1 through 30. So I'm going to get students, let's see if I can do it in Excel to make it make some sense. So I'm going to get all this data. And let's think about what data we're going to need. So from each student, I'm going to need something. I'm going to need student ID. I'm going to need classroom number. And I'm going to need the score. So that classroom number, it could be anywhere. So each 30 classrooms numbered 1 through 30. Our student ID, we really don't have an idea about that, do we? We could make one up. And in this case, that student ID, oh, 1 through 30, make that a general format cell. Not really a you have numbers. All right. So that one's 1 through 30. Thank you. All right, it was 1 through 30. Going to argue with me here. This one, your score is 0 to 100. Now that's an interesting score. How many possibilities are there for a different score? 100 or 101? So if I start counting from 0 and I go all the way to 100, am I at 100? Yeah. It's 101 possibilities for a score. Yeah, so you could have a 0. Hopefully you wouldn't. And this one we can just make up a number because we don't really care what it is. So think about then, I have all this data and I have a number. So now I need to manipulate that data. They're in classroom 4. They got a score of 94. So the first one says we want to write a program that takes all their data. So we could do that pretty easily because you're getting these 3 pieces, and those could be all parallel arrays. And we know that that array has a limit on size. So it's 30 classrooms and up to 35 students. So what's the maximum size of that array? So 1,050. That's a big chunk of data. But 30 classrooms times 35 students in each one. That means we need to store this list here could be up to 1,050 names. So student ID, classroom, and score. Now, there might be some better ways to do that than putting it into one single array. But could we search through that and find all those classrooms and output an average? So we have all this data. We could create a loop of some sort to look at classroom 1, classroom 2, classroom 3, and identify all of the parts in there. So you might have a loop inside of a loop, though, would be the one harder issue with that. Now, other languages and other ways we could think about that, if we could create an array inside of an array, but we're not really quite there yet. But if I get all this data, so all I really have is a while not end of file input data about the student. We don't have any error checking probably, so that we don't have a 36th student in there. And that's probably okay, because what we want to do is show how you can pull that data back out and start manipulating it. And so your output might well be an array. So here's our array for scores. So maybe you call that one scores. So 1,050, there'd be a lot of data there. You might have one for classroom. What are we calling it? Classroom average? Total points. Class total. And how many classrooms do we have? 30. So you could have one that you're going to find the data for. So what I would do if I were going to try to extract data back out of here is I would probably use something like a while loop structure. So while not end of file. So in other words, as we search through that entire list of values, I would search for, I would probably put a loop inside of there. And the first loop I would have is while class number is less than, and I wouldn't hard code it in there, but just to show you what I'm doing. So while class is less than 30, I would probably search through that entire loop. And I would do it one at a time. So I would then output that data into this array here. So as I add up those scores, I would then output them into this class total. And so I would end up with an array of scores. That's one way to do it. There's lots of other ways to do it. All right. So make sure you watch. Remember, I lost it here. Everything's open. So watch this video here. It's in week 5. So there is a homework how-to video. Again, if there's any dates or anything referenced, make sure, because this I did grab last year, but it actually goes through, and I go through how to create some structure and how to look at it. Again, not the only way to do it, and you certainly may find better ways to do it. So as you're thinking about it, try things. Don't necessarily just copy down what I have. Try to come up with your own method to do that. There's lots and lots and lots of ways to do it. I have some sample problems available. So number 6 has got a sample. I have that video, and I will actually probably make this. That is one way we did it. So I'll probably make a piece of that available, not the entire thing, so you can see what some other ones we looked at. That's actually the output of the video that we created. But if you just start there without seeing how we got to that point, I think you're going to be a little lost. So we're amping up the structure a little bit. The one piece that will be easier next week and the weeks after when we start doing it actually in Python is in Python you get to actually run the code, and you can quickly see where it crashes and burns. But you have to know how to start where and start logically how we can break apart those to get to that point. All right, any questions right offhand? Anybody want the temperature to be warmer? Yes. It could be worse. I had a friend of mine posted on Facebook, wherever they're at, that it was minus 27 real field, or not real field, but the actual temperature where they were at. They work for a construction company, and he flies all over, and that was his temperature today. I didn't feel quite as bad when Alexa told me it was like 4 degrees below zero. All right. If no questions, I'm going to close this out, and I'll pop this one available.